So they don't want to teach junior high. Okay, so equivalent rational expressions. Equivalent rational expressions. So open up. Now, this will all be in a coiled book that you'll get. It will come in, I'm hoping, Monday or later today. So it's just for the meantime. Okay, so writing equivalent fractions. So just before we start, if I have a fraction of 1/2, can somebody give me an equivalent fraction? So what is 2/4? What's another one? What was that? 150 over 300? Is that what you said? 50 over 100? Yeah, so that's an example of equivalent fractions. We can do the same thing. This is also equivalent to 150x over 300x. Still equivalent. Why? If we reduce that, the x's reduce out, and we still get 1/2. Okay, so these are all equivalent fractions, equivalent ratios. So equivalent, notice the equal, right? We're talking about equal fractions. And then rational expressions, remember ratio is a fraction. So we're talking about fractions. The value of a shipment of identical televisions is $4,500. The number of televisions is unknown. Determine a range of possible costs for each television. Okay, so what would give us a total cost of $45,000? It would be the number of TVs times the price of each TV. So number of TVs times the price of each, of one TV. And that should equal $4,500. $45,000, thank you. 45,000. So if we call the number of TVs N and the price, I don't know, we can call it P. C for cost. What do you want? P for price equals $4,500. It says determine a range of possible costs or possible prices. So we want the price by itself. And so if I took $4,500, $45,000 actually, I keep saying $4,500, and I divide it by the number of TVs I have, it'll give me the price of each TV, right? Would you agree with that? If I had 100 TVs, if I take $45,000 divided by 100, would it tell me how much each TV was?
How do you know the price of a single TV?
We don't. So it says determine, we have to make a rate, come up with some possible answers. Okay. Can you have 0 TVs? No. You have to have a minimum of 1. Yeah. Minimum of 1. So if we had 1 TV, then what would be the price? $45,000. So that's probably, so number and price, $45,000. Okay, what if there was 10 TVs? How would you get the price of each TV? 45,000 divided by 10, which gives you 4,500. What's another possibility? 45. Yeah, so chances are that's not realistic. What if there's 100 TVs? 450, is that a little bit more realistic? Yeah. How many solutions are we going to have? 1, all the way to almost unlimited. Yeah, almost unlimited. We could put the number of TVs is 45,000. That would be how much for each TV? $1. But it's not realistic, right? So there's some possible values. And so here's an example of a rational expression when we have a variable in the fraction. Here's our rational expression. Okay, moving on. Yeah, okay. A rational number is the ratio of 2 integers. A rational expression, so a rational number is the ratio of 2 integers. A rational expression is the ratio of 2 polynomials, right? A polynomial has a variable in it. strategies that are used to write equivalent forms of a rational expression are similar to those that are used to write equivalent forms of a rational number. So say you wanted to make 1/2 equal to 2 over 4. How did we make those? How do we know they're equivalent? What happened to this fraction? We times the top and the bottom by 2. The same for polynomials. If I want to make an equivalent ratio for x plus 2 times x plus, or divided by x plus 4, I could still maybe double it, but you just have to be a little bit careful. When you have a binomial or a trinomial, that 2 has to apply to everybody. So 2x plus 4 over 2x plus 8 is equivalent to x plus 2 over x plus 4. Okay, so that's what we're going to practice doing today. 2 things, writing equivalent ratios. So you might have seen that before. Yeah? No? And then NPVs. I just picked randomly, just for an example, for equivalent. Yeah, you can pick any number, right? So your homework, there'll be multiple solutions. All right, so you can multiply the numerator and denominator by the same factor or divide the numerator and denominator by a common factor. So those are the methods. Important things to remember. This is huge, actually. All rational numbers is undefined when the denominator is equal to 0. Why is that? Yeah, can't divide by 0, right? Number over 0 cannot do. Oh, okay. Choose this one. It's prettier. As a result, all rational expressions are undefined for the values of the variable that make the denominator equal 0. And we call those non-permissible values. You might have heard that before, some of you. Okay, so non-permissible values are NPVs. We call them NPVs. Are the values that would make the denominator equal to 0. So for example, if I had 1 over x plus 2, what value of x would make the denominator 0? -2. So our non-permissible value would be x. Where's the x? Sorry. X cannot be equal to -2. That's the non-permissible value. Non-permissible is just like a fancy word for a number it can't be. Big word. You have to figure it out from factored form of the denominator. So this one, it's just a binomial, so it doesn't necessarily need to be factored. If there is a GCF, we pull that out. So that's how we figure out the NPVs. We're going to have to factor. And that's where I told you this, the focus on this unit for us is simple trinomials, greatest common factors, and difference of squares. Complex will come up once in a while. It shouldn't show up on your diploma. It's not saying it won't, but looking at all the diploma questions that they've written so far and looking at the diploma that they wrote in the September is just simple trinomials, GCF, and difference of squares. So that's a good thing, because complex is where it gets a lot harder. Okay, substitution can be used to determine if 2 rational expressions are not equivalent, but cannot be used to determine if 2 rational expressions are equivalent. And I'll show you an example of that after. So let's look at an example. So write 2 rational numbers that are equivalent to 8 over 12. New thing that you guys can do now. Do you have 2? Yeah? What's one of them? What did you do? Did anyone get 4 over 6 or 2 over 3? So if you got, Jesse, how did you get 2 over 3? Both we can divide by 4. And that gives you 2/3. Yeah, or you can have 4, 6. Anyone multiply by anything? Anyone multiply everything? Like top and bottom by something? No? Like a lot of you simplified that way instead? We could also expand it, right? Make it a larger number by, we can multiply by 2 or 3, or you could even do 100.
16 over 24.
So 16 over 24. Same with 800 over 1,200. Right? 18, so you times by 3? No. 18 over 12. No. 8 over 12 and 18 over. No, it didn't. Check it again. 12 divided by 8 divided by 12. What do you, let me see what you're thinking.
26.
That's the same as 2 over 3, right?
Yeah, 2/3. 12 over, no. 12 18ths. You said 8. You said 18 over 12.
Oh, okay.
Yeah, 12 18ths. Yes. Yes. Yeah, times by 6 and 6. Okay, so let's do the same thing for this guy. We want to write 2 equivalent. Why not? Want to do it together then? Yeah? Somebody want to write theirs? I wrote it down wrong? Yeah. And try, Kayla. No? It's this new thing I'm
That's really
trying.
cool. I saw the thing come up.
Okay, so we can write yours there.
You threw that all in your hands.
Yeah.
Nice.
Is it working?
Yeah, that's really.
5.
Can we just say it?
I messed that up too.
Okay, wait.
How do you erase?
This is a key.
It's supposed to be 2.
Eraser is right down here.
Where is it? This is really hard to do. Alright.
Yeah, we're gonna have to work on this, and then
Okay.
there you go.
2.
There you go. That's 1. So x squared plus 2x. So what did he do? He divided everything by 4. So divide by 4, divide by 4, divide by 4. How about for x? Yes, I do. Do the other scheme? Okay, next time. So divide it all by 4x. So what it would be, that's another one? X plus 2 over 1. Yeah, that would be another one, or just x plus 2. What's another one? What else could you do to this to make an equivalent fraction? So divide everything by 2. That's what you did. So 2x squared plus 4x over 2x.
On the test, would they ask you to find like more than the most simplest form or something?
Yeah, we're gonna have to do that later on. We will learn that. Yeah. Did anyone multiply your fraction by anything? Yeah, what did you multiply it by? 4? So you had, I'm just gonna circle all our different equivalents. You multiplied yours by 4, so you had what? Yeah, you could even multiply it all by x. So 4x cubed plus 8x squared over 4x squared. How many answers are there, Dean? Infinite. Infinite. Oh, sorry. Infinite. Okay, so that's writing equivalent fractions. Not so bad, right? You could do that on your quiz tomorrow. So there'll be multiple solutions. So I'd have to hand mark that. I'll ask you to write an equivalent fraction, and then I'll just mark it myself. Okay, non-permissible values. So non-permissible values are the values that make the denominator 0, because we cannot divide by 0. Just doesn't exist. Right? When we graph that, if we look at these graphs, so if you take your graphing calculator and you look at some of these graphs and we graph it in our calculator, it's going to make something called an asymptote. So a line that it doesn't touch. We'll look at those too. Okay, so looking at this guy, when we say non-permissible values, just look at the denominator. And what form might you have to put it in? Not this time. What might you have to do to the denominator to figure out the non-permissible value? You may have to factor it. Okay? You may have to factor. Can you factor this? No. Okay, so what's the non-permissible value? What our NPV? What can't x be here? 4. So another way you could also set the denominator equal to 0 is another way to find it, and then solve for x. So add 4 to both sides, and that's how we get x equals 4. Or just use mental math. What minus 4 will give me 0? 4 minus 4. Okay, the next guy, could we factor anything out of that? Make it a little easier. What can we divide both negative 3 and negative 15 by? Negative 3. So let's rewrite this. It's negative 3 times. So if we're factoring out the negative 3, we have to figure out what's on the inside. We're dividing each number by negative 3. Negative 3x divided by negative 3. X plus 2 negatives. Negative 15 divided by negative 3 plus 5. Okay, so what's my non-permissible value? It's only where the x is. X can't be equal to negative 5. Why not? No, you're thinking about before things cancel. Because even if you put negative 5 in here, that would you could still figure it out. Yeah? Did you just go? Yeah, so that's the other option. You just set negative 3x minus 15 equal to 0. So you added 15 divided by negative 3. You just figured it out. Yeah. That's totally fine if you have GCF. There will be math later on in the future where you're going to have to factor out because things are going to start to cancel on the numerator and denominator. So you might want to pull out the GCF. But if we're just looking for NPVs, that's totally fine. Okay, next guy. What can we factor out of this denominator? We're not simplifying right now. We're just finding NPVs. We only need to worry about the denominator. You're jumping ahead of us, so you already know what to do. Okay, we can divide both of these by x. So wherever there's an x, that's where we're going to have a non-permissible value. So there's 2 non-permissible values here. There's two numbers for x that would make the denominator 0. What would they be? What's one of them? 5, because 5 minus 5 would give you 0, and 0. Because 0 times 0 minus 5 is negative 5. It'd still be 0. 0 times anything. So for each x, there's going to be a non-permissible value. There's no constant being added or subtracted. It's just 0. How are we so far? Those of you seen this before, boring a little bit? Yeah? You can start the homework if you like. 2 more examples. One's there and then one I'm going to add. So you'll have to write it below. One hose can fill a swimming pool in Y hours. A larger hose can fill the same pool in 20 minutes faster. Write a rational expression for the fraction of the pool that is filled by the larger hose in 1 hour. Okay, this might seem a little confusing at first. Okay, so if it takes me 2 hours to fill the pool, in 1 hour, how much of the pool is going to be filled? Half. If it takes me 3 hours to fill the pool, in 1 hour, how much would be filled? 1/3. So it says, write a rational expression for the fraction of the pool that would be filled by the larger hose in 1 hour. So we first need to figure out the time, like write an expression for the time for the larger hose, because it tells us that the smaller hose is y hours, and it's 20 minutes faster than the large hose. So what would be an expression for the time it takes the large hose to fill the pool? So if the small hose is y, the time for the small hose, that means the time for the large hose to fill up. How can we write it in terms of y? Would it be y plus 20 or y minus 20? Y minus 20. If it's 20 minutes faster, it's y minus 20. Yeah, Priscilla? Okay, so we said you have 1 hour, you've been filling for 1 hour, and this is your total time. So the fraction that's been filled in 1 hour would be 1 hour over your total time. How much time you have filled over your total time. So that would be the fraction of the pool that was filled. Right? How much did we fill for? So far it's been an hour, and this is our total time for that hose. Okay, so what are the restrictions on this? Y can't be 20. And why can't it be 20? Let's explain. Why can't it be 20 minutes? Who is Y? The large or the small? The small. Yeah. If we know this is 20 less, right? So if it took 20 for the small hose, then the large hose would be it would take no time at all, and that's not possible. So if Y was 20, so that's the time for the small hose. Then it would take no time, or take 0 minutes to fill with the large hose. Uh-oh. Okay. What are the restrictions? That's a non-permissible value. Is there any restrictions on our domain or this graph? So we said it can't be 20. Could it be 10? Because it's always 20 minutes less, right? The larger hose takes 20 minutes less. So can it be less than 20? No, because then you'd have negative time for the other pool, and you can't have negative time. So in this situation, our y has to be greater than, not equal to, 20, because it's a word problem. So that would be the domain of this graph. So this would be the restriction on the rational expression, and this would be the restriction on the whole word problem. No, because if it was equal to, it would be divided by 0. Yeah, so above 20. Okay, I'd like to do one more question with you. So there's a little bit of room at the bottom of the page there. So if you can maybe write this down here. I'll give you some time. So can you write down the first part of the question? I want to show you a chart. James is running along his usual 5-kilometer loop. One morning he runs 6 minutes faster than his normal time. It's not there, so just if you can write it down, I wanted to add it. Because there's a question like it in your homework. Nope, that's for tomorrow. And then your homework's in the blue book. This will be the last question of the lesson, yeah? Maybe. So on your diploma or on your unit exam, the curriculum says that you have to either do one or the following, but not both for us. So you may have to make from a question, make the formula, make the equation. Or they give you the equation, you solve it. But they will never ask you to make the equation and solve it, both. Okay, so it's going to be either just make the equation or the equation's given and you solve it. That's what you'll see on your diploma. Whereas I think I guess it's 20-1. You'd have to make the equation and solve. Okay. So maybe some people who've seen this kind of stuff for speed before, what can you do with a speed problem? Did you guys make charts ever? No? Can I make a chart with you? Okay. There's speed, which is rate. So rate is distance divided by time, right? So rate, distance, time. Okay, I cannot draw straight. I don't know about you. RDT. All we need is a V. Did everyone ever watch RDTV? No, I'm dating myself. Back in the day, that's Mike Sobel, who does the weather. He used to run like a children's Sunday morning thing. And there's always like good shows on RDTV. So we have our two situations. Okay, what are our two situations in this problem? It says James is running along his usual 5-kilometer loop. One morning he runs 6 minutes faster than his normal time. So what are our two situations? He likes running. Okay, what's the two things that are happening here? So he always runs 5 kilometers. That's his usual loop. 6 minutes faster than his usual time. So this is his new time. We have his new time and his usual time. Okay, the usual and then the new. Now the formula you need to know is rate or speed is distance over time. And I think most of you know that formula. Science 10, remember those good old days? No? Those were good days. Okay. So what do we know? What do they give us? Distance. What's a distance? 5. It's always 5 kilometers. It says write rational expressions for his speed. So we want the distance divided by his time. So his usual time we'll call t. Sure. And so what's his new time if he's 6 minutes faster? T minus 6. And so his usual speed would have been his usual distance over his usual time. And now his new speed is his new same distance over 2 minus 6. So his speed now is 5 divided by t minus 6. These charts are really going to be helpful for speed, rate, time problems, or speed, rate, time problems. So what's the non-permissible value here? Time cannot equal 6. Yeah. And why can't he be 6 seconds or 6 minutes? If his usual time was 6 minutes, then it would take him how long in the new time? 0 to run 5K. Okay. What are the restrictions in Part A? So what are the total restrictions? Can it be less than 6 minutes? No, it has to be greater than 6 minutes, because if t was less than 6, you'd have negative time, because we can't have negative time. Alrighty. So that's it for notes for today. Your homework is, if you want to open up to page, someone know the page number already? 90. Okay, on page 90, the first part is just notes. So if you want review of something, you can read through these. And then the homework starts at 1. So it's 1 all the way through, all the way here. Okay, 1 through 8. The answers are on School Zone. So if you need to see them, if you ever have like a tablet or your phones, as long as you're allowed to listen to music, remember no texting. If I catch you gaming or texting, then I'm going to take it away. You can use your phone for a listening device as long as you're not texting on Facebook, right? Fair? Just during class. And then on the website, I know some people in 20-2 would pull up the solutions and have them open while they're working. 1 through, yeah, so all of it. Yep, go ahead. All right, Dean. Sawyer, did you want to move to that side to see better?
Yes.
During the lesson, yeah?
Oh, during the lesson, yeah.
Yeah, you're here now, but during the lessons.